This is your lesson for 3-7, transformations of polynomial functions. And we're really only looking at a very small part of 3-7. I'm not going to go back and revisit a lot of the transformation stuff that we did back in chapter 1. However, we are going to focus on symmetry and the idea of even and odd. So that ties into the essential question. How are symmetry and transformations represented in the graph and equation of polynomial functions? So this is your concept of odd and even functions. Even functions, which is going to be the graph that is on the left-hand side, they are symmetric about the y-axis. That means that the y-axis acts as an axis of symmetry. You can fold it over on the y-axis. It's going to repeat on both sides. Odd functions are symmetric about the origin, which means if you rotate your graph 90 degrees, you're going to end up with exactly what you started with. If it's neither, that means that there is no symmetry about the origin or about the line of the y-axis. Now, it is important to note, for even functions, and this is how you can look at it with the equation if you don't have the graph. If f of x and f of negative x give you the same value, then it is an even function. If you plug in a negative x and you get back the negative of your original function, it is going to be an odd. And if those things do not happen, then it is neither. That's neither even nor odd. So our first example, we're going to look at a couple of equations, and we're going to decide whether they are even, odd, or neither. So you can see for part A, we do have that arrow drawn on there, and that actually looks very similar to what we had in the example. So I have the point 1, 1, and I have the point negative 1, negative 1. So if I negate the x, I get back the negative of the y that was there, which means this graph is odd. I believe that for what we are doing in here, all odd functions have to pass through the origin. The only exception to that would be if you have something that's undefined at the origin, but it's the same, it's like opposite on both sides. But for what we're doing in here, they have to pass through the origin in order to be odd. Part B. Notice if I were to split it on the y-axis and flip it over, it's going to look the same. So that graph is an even polynomial. It is even. Part C does not pass through the origin. If I were to rotate it, I'm not going to get the same thing that I had. And if we fold it over the y-axis, it also doesn't look the same. So that graph is going to be a neither. Now we're going to look at equations. This is where things can get a little more difficult. So this is something to keep in mind, especially if you don't have a graphing utility and you're not sure what the graph is. So the best thing to do would be to replace your x's with negative x's and see what happens. So for part A, I have 4 times negative x to the 4th plus 5. Well, if you have a negative raised to the 4th power, that's just going to give you a positive answer. The 5 does not change sign, which means part A has to be an even function because it's exactly the same as what we started with. If I look at part B, if I plug in negatives there, a negative raised to an odd power is going to remain a negative, so this is going to become negative 2x cubed minus 3x. That is exactly the opposite of what we started with, which means this one has to be an odd function. As a general rule, even functions, if you're looking at polynomials, even functions have to have all even degrees or constant terms. So this 5 kind of acts as an even because it's technically typically 5x to the 0 power. 0 is considered part of the even exponents, even though 0 is not really an even number. So if we look down here at this h of x term, I have a mixture of odd and even, because I have an x to the fourth and an x to the third. That is a dead giveaway that this is neither. You cannot mix odd and evens. We look over here at the p of x. Well, I have an odd exponent with the third power. I have an odd exponent with the first. But because of the 1 at the end that acts as an even, this is also going to be a neither. So this is neither odd nor even as well. That is really all I want to cover from 3-7, just recognizing odd and even functions. That will come up again in the future, not necessarily in my class, but I know it comes up in trig pre-calc when you're talking about different trigonometric functions. So I wanted to make sure that you guys were at least exposed to this topic. So go back through, rewatch this video, and reach out to me if you have any questions.